Okay, this is a presentation designed to help teachers and students with a small part of the new combined science curriculum being offered by AQA. This is off the draft spec, but basically there's a formula in here, v squared minus u squared equals 2as, that all students will need to be able to use, not just people doing the three or single awards, not just people doing higher tier, but it's going to be for all students. And my guess is it's probably something that will give quite a few marks because there's quite a bit of manipulation of the formula might be needed. And this is my suggestion as to how it be taught. I hope you find it useful. Okay, so we start by looking at one of the slides I've included on Google Drive for staff. You get students to think about this object and what it would be doing. Hopefully they'd come up with, well, it's not doing constant speed, it starts at a certain speed, or velocity, sorry, then increases. Once you've done that for a bit, change the question to how might you work out distance travelled or acceleration, and what numbers would you need. This should get students thinking about the fact they'd need the initial velocity. Let's pretend that by the way is 10. This will help them later on. So imagine it was 10 meters per second, okay, and then they'd need the final velocity and the time. So if just for now we pretend that we did know the numbers and that it was an initial velocity of 10 meters per second, it accelerated to 20 meters per second, and let's say this all took 5 seconds, you might have a quick discussion about what you could actually work out. They should notice that you can work out the area, which would equal the distance, and the gradient, which would equal the acceleration. Okay, so I would big this up a lot now. I would really get the students hyped up or switched on to the fact that it's going to be challenging, but it's worthwhile. And actually, they will be able to, and students should be able to, by the end, be able to present and explain this to other students, the derivation of the formula that we're going to use. Okay, so I'll go through it now. The text in red is just the explanations. So, first things first, we've already encountered the letter U, V, and T. These letters represent initial velocity, final velocity, and time. And now we've got S for distance. Okay, so let me just switch to present mode. Okay, so average velocity would be the total distance divided by time. We could also describe this as V plus U divided by 2. So let's pretend, using our pretend numbers from before, if V was 20 and U was 10, then you'd have 20 plus 10 divided by 2, which would get you 15 meters per second. So you can see it does work. The next step is we equate the formulas, which means we take this part and make them equal to each other. Okay. Then we can simplify it and make S the subject. So I've just taken the 2 from underneath and made it come out like that, so as half multiplied by that, same thing. And now I can multiply both sides by t, both sides the equal sign by t, which should basically cancel the t out on this side. So this is equation number 1. It is a SUVAT equation. It's what you teach in A-level physics or mechanics in maths. So, but it's not the one that we need actually. We can treat each of these little red bits of text here as a question you could actually ask students. So what does equating formulas mean, or how could we find the average acceleration, average velocity, etc. Or for instance, how could we work out the acceleration using the graph here? So if you want to get the acceleration off the graph here, you could use gradient, change in y over change in x. In this case, that would be the final velocity minus the initial velocity divided by time. Let's rearrange it for t, so we can multiply both sides by t. I've just expanded actually how to rearrange the equation here, because again, students will need reminding from their maths classes. Even good students will struggle to apply initially, but they get there in the end. Okay, so multiply both sides by t, we can cancel the t's, so that gets us that, and then divide both sides by a, right, and then we can cancel the a's, and we get to t is equal to v minus u over a. A lot of students will say, I know an easier way, I know a quicker way of doing it, and they'll talk about floating numbers across, or because it's times you divide, or something like that. And in my experience, students can get the answers right sometimes using that, but the problem is that they can't confirm that they're correct, and if they are a bit nervous or make a mistake, they have no clue why they made the mistake. So it's just better, I think, to just do it the long way, and and get it right. Slow and steady wins the race. Okay, so now we've got this equation number 1 and this equation here. We're going to substitute our value for t, or the term we've made up for t, into this equation. So it's literally taking this chunk, sticking it in there. Again, I've made this looks a lot more complicated than it is, but I've just expanded every single step so that a student with the weaker math skills can follow each step and still feel invested in what you're doing. Okay, so this times this, we put the 2 back underneath basically, so the top things in both these parts of the equation are multiplying each other, the bottoms are, so we get to here. Now we want to multiply out the brackets. Now students will probably have been taught a method like this where you do that first, then that. So here we'd have v times v, which gets us to v squared. Then we would have v times u, but it's negative u, so we get minus uv or minus vu. Then we could do u times v, which again is uv, right? Positive uv, and then u times u, which will be negative u squared in this case because the u is negative. Okay, so that's what this has got us to. S is equal to v squared. Because the minus uv and the positive uv can cancel each other out, they're just subtracting off each other. We're left with v squared minus u squared over 2a. Okay, and then finally, to put it in the format that the AQA has presented us with, we can multiply both sides of the equation by 2a, which will cancel it from this side and gets us to v squared minus u squared equals 2as. So quite a bit of a challenge to get there, but it's worth doing, and you can talk through each of the steps. It's good for their maths, and it's very good for their physics, because really you can't understand physics without knowing, I don't think, where the equations come from.
Okay, so let's start try rearranging for the various components of this equation. Make v the subject. Okay, so you should have a go at this yourself, test your algebra, but here is how you do it. So I need to get rid of the u squared on this side, so if I add u squared to both sides of the equation, I will get 2as plus u squared, and then if I take the square root of both sides of the equation, the root cancels, so I end up with v equal to root 2as plus u squared. Okay, make u the subject of the equation. Okay, so I'm going to do this a bit differently. So v squared minus u squared is what we're starting with, equals 2as. Now, because this minus sign makes things a bit awkward, there may be easier ways of doing this, but this is the way I always have done it. I'm going to multiply both sides of the equation by minus 1. Okay, so that would make minus v squared plus u squared equal to minus 2as. Okay, and now I can add positive v squared to both sides of the equation, which will cancel it from this side. So this becomes positive v squared, and again take the root, which cancels the root here, so it cancels the square there. So I end up with u is equal to square root of minus 2as plus v squared. Okay, make a the subject of the equation. Alright, so I've got again v squared minus u squared equals 2as. If I divide both sides of the equation by 2 and s, 2 cancels with 2, s cancels with s, so I end up with a is equal to v squared minus u squared over 2s. Okay, again make s the subject of the equation, very similar to before. v squared minus u squared equals 2as. Dividing both sides by 2a, cancels the 2, cancels the a, so s is equal to v squared minus u squared over 2a. Okay, and finally I'd just like to show how you can demonstrate that it definitely works, and that the equation that we came up with previously, the v squared minus u squared equals 2as, ties in with all their previous knowledge about what they've learnt in terms of velocity time graphs, etc. So let's make up some random numbers. Right, let's pretend that we know this thing started at 10 meters per second, accelerated up to 20 meters per second, right? So let's see what all these values would work out to be, okay? So if you was to ask what's the displacement, well, we could work it out. If I give a few other bits and pieces as well, if we say this happened during 5 seconds, so we could say, well, the distance travelled will be the area under the graph. So that's the area of this rectangle plus the area of this triangle. The area of this rectangle is 10 times 5, so that would be 50 meters. The area of this triangle, well, its height is from 10 to 20, so its height is 10. It is 5 wide, so it is 50. So it's going to be 10 high. I'll add it on here. It's 10 high. It's 5 wide, so it's going to be 50 meters. But you have to divide it by 2 because it's not the entire area of this entire rectangle, it's just half of it. So it's actually 25 meters for that little chunk. So the sum of these the total area is 75 meters. Okay, so the initial velocity we've already written down was 10 meters per second. The final velocity was 20 meters per second. The acceleration we can work out, it's acceleration equals delta v over t. Okay, delta v over t, so it goes from 10 to 20, so the change in velocity is 10, positive, and it took 5 seconds, right? So that means it is 2 meters per second squared. Okay, and time was 5. So here is a set of results that we know are true and consistent within the formula. Now let's pretend that an examiner asks us or tells us all this information apart from the 20 meters per second. We don't know what the velocity is going to be. Let's go back and just use the equation we've already rearranged for. Let's see, it's v equals 2as plus u squared, all rooted. So if we try using that equation, v equals 2as, hold on a second, 2as plus u squared, and it's all rooted, plus u squared, and it's all rooted. So let's sub the numbers in and see if it works. So it will be 2 times 2 times 75 plus u squared, and u squared is 10 squared, and that's all rooted. Okay, so it becomes 2 times 2 is 4, 4 times 75 is 300, plus 10 squared, which is 100, all of that rooted, so it becomes 400 rooted, right? The root of 400, checking out my calculator, is 20, and it's velocity, so it's meters per second, so you can see it works in this scenario. Let's try for u. Let's pretend the examiner gives us everything apart from u. So we have got this value, but this time we haven't been given this value. Okay, so the question is a car travels 75 meters, its final velocity is 10 meters per second, it accelerates like this, it takes 5 seconds, so you'd have all that information and you have to work out u. Alright, so again, let's go to, we could start with the original equation, but I've already rearranged it, so we may as well use this. U is equal to minus 2as plus v squared. So u is equal to minus 2as plus, hold on, get the u's and the v's mixed up because my handwriting's terrible. Bad handwriting costs marks, v squared. Right, so u is equal to the square root of minus 2 times, acceleration is 2, times 75 plus v squared, and that's 20 squared. Okay, so u is equal to the root of, now minus 2 times 2 is minus 4 times 75 is minus 300 plus 200 squared plus 200 squared. So 200 squared I think is going to be 400. Sorry, 20 squared is 400. Yep. So 400, so we end up with minus 300 plus 400 equals the square root of 100. Okay, and the square root of 100 is 10, and it's velocity, so it's meters per second. So value for u came out as 10 meters per second, also agreeing with what we had previously. Okay, I hope you found this useful. If you would like any additional help or tips, please comment and say what you thought. Thanks for watching.